Here's Precal, it's problem 4-60. The graph of f of x is shown at right. Below are graphs of g of x and h of x, which are transformations of f of x. Write equations for g of x and h of x in terms of f of x. So here's the f of x. So that's the original graph. And so we're thinking in this problem, we're thinking about a, h, and k, the parameters that we use to transform functions. A is a vertical stretch, h is a horizontal shift, and k is a vertical shift. So we're thinking of all those kinds of things. And also we know that if we take like a negative f of x, that it will flip it over the x-axis like a reflection. So what we're going to do to start is we're going to look at our graph, look at the graph of A, and then just at first we're just going to take a guess of what might have happened. I know you can see the answers, but when I compare letter A to like g of x to f of x, what do I notice? Well, I think that it looks like f of x got like flipped upside down. So I'm going to start there. And then if there's something else that happened to it, maybe it got a vertical or a horizontal shift also, I'll deal with that after the obvious thing to me is that there was a reflection. So I'm going to actually just draw in my book a little bit what this reflection would look like. If I reflect f of x over the x-axis, this point here is going to come down here. So this piece here would get reflected down here. And this point here, let's see, that's 1, 2 away from the x-axis. So I'm going to go up by 2. And then that gives me this piece right here. And so it looks something like this. The one that I just drew in pencil, that's just negative f of x. And that looks a little bit more like what we see here. But it's not exactly, because I see that this piece up here is lifted up higher. So I think this graph must not only be reflected, it's also probably got a vertical shift. So I'm going to look and see how far I need to shift it down. So 1, 2, 3. See, this graph down here is at -1. So, and I have to shift this graph down by 3 to get this piece to land on -1. So since I shifted down by 3, it has the -3 on it. That's like you guys are used to k, like A, H, and K. And then the negative sign means it got flipped, over the x-axis. So this one's the one that's a little more difficult. Letter B. So letter B, we'll start with just trying to notice anything. The first thing that I really notice is that it appears to be have a vertical stretch to it. So I guess we can start with that. So I think that f of x must have gotten stretched. And so my first thing I want to try is find out what it got stretched by. My guess would be 2, so I'm just going to see if I think that's true. So like this is 3 and 3. So it's kind of like the difference in the height from, I'm using these 2 points right here as like locator points. I noticed that there's this bigger stretch here, so that's like the vertical distance. Instead of 3, it's 6. So I do believe that this h of x is 2 times f of x. So that explains the 2 out here. This is just the answer, because you're looking at the answer book. But really, when you stretch something, what happens is that the y coordinates get multiplied by 2 if the stretch factor is 2. So I'm using these 2 points as my locator points. This point is 2. Oh, let me plug this in. Losing power. Okay. It's 2, 1, this point right here. It's 2 comma 1. So if I multiply my y value by 2, I'm going to end up at 2, and it's just a vertical stretch, not a horizontal, so it's just the x will stay the same. This point should move to 2 comma 2. So it should move to there. And then this point is -1 comma -2. I'm going to, since it's a vertical stretch, I'm going to take the y, because that's the vertical part, and multiply it by 2. So that gives me -1 comma, well, -2 times 2 is -4. So this one would actually end up down, instead of at 2, it'd be at -4. Let me get rid of this slope triangle, because that's makes it even harder. Oops, and then I was just counting to make sure it made it up. Okay, so this is now 6, and this is 3. That's 3, that's 6. Okay, so this would be what happened to f of x. If I just simply take f of x and stretch it by 2, I get this graph. So I'm comparing it to h of x to see if I'm done or not, or if I have to do something else with it. I do see that this one is, like, I think I need to shift f of x back by 1. Because see how this is like the x-coordinate is 2, and this one, the x-coordinate is 1. So if I shift the whole thing back by 1, that's that'll be x. Remember how it's x minus h? So x minus -1, so that's x plus 1. So that accounts for the shift. So now I've shifted everything back. Or when I say back, I mean to the left. Now I've shifted everything to the left by 1. And then we'll see what we have after we do that. So now we've got this. I mean, it shouldn't be this complicated. It's just there's a lot going on in this graph. Okay, so now, is that enough? Like, does my new f of x, now I've multiplied it by 2, or I've stretched it by 2, I've shifted it left by 1. Does it match? No, because see this point, that should be up at 4, like this one. And even down here, see, this is like at -1. So I need to lift it up by 2. This one also, it needs a vertical shift of 2. See, because this point right here, the y value is 4, and this y value is 2. So if I shift everything up by 2, and then even this one, like over here we're at -2, but over here we're at -4. So just, that's what the 2 is right there. So if I shifted it up by 2 like that, then it'll match. I know, it's a lot. Now this pencil drawn one matches h of x, and so if I recorded everything I did, remember the first thing I did is I multiplied the y values by 2 to give the vertical stretch, and then I moved everything left by 1 and up by 2.